Here we are with your lesson on equivalent ratios. Ratios are equivalent as long as the multiplicative relationship between the two quantities is maintained. It is a multiplicative relationship at all times. What I mean by multiplicative is two quantities could be related by multiplication, or as you now know because of inverse operations, by division as well. Here is an example to kind of get us started thinking in the right direction. For a cake recipe, Herman needs 2 eggs for every 3 tablespoons of vegetable oil. Over here, I set up a little table to just kind of get us thinking in the right direction. When we're making cakes, sometimes you can buy mixes, but if there is a recipe from scratch that you might make, then you might not always have the right number of ingredients. You might want to make a smaller batch. You might want to make a much larger batch. And so because of that, ratio relationships are going to be really important. So if the recipe calls for 2 eggs for every 3 tablespoons of vegetable oil, then what if we wanted to double the recipe? Well, if we wanted to double the recipe, I would think multiply by 2. So I would say, well, 2 eggs, if I wanted to double that, that would be 4. And therefore, I would also have to double the amount of oil. So this is not additive. This is not me adding 2 eggs. It's multiplying the recipe by 2. And so if I wanted to do that, I wouldn't just add 2 tablespoons of oil because I added 2 eggs. I would multiply the tablespoons of oil by 2. So 3 times 2 would be 6. Now, what if I wanted to have half of a recipe? So we know that we could either multiply by 1/2 or we can divide by 2. This is how multiplication and division are so closely related. So if I wanted to divide the number of eggs in half, I would divide by 2. So 2 divided by 2 would be 1. And now I would divide the tablespoons of oil by 2. Well, 3 divided by 2, that's 3/2 or 1.5 tablespoons of oil. And we could write that as either 1 1/2 or 1 5/10 the decimal. The point to this is, for the cake to taste right, the ratio of eggs to oil must be equivalent, no matter the amount of cake being made. We could make a huge cake. Let's say we wanted to make a cake that is 5 times the size of the original recipe. Well, we would multiply the number of eggs by 5. And so we would need how many eggs? We would need 10 eggs. And because I had to multiply that by 5, I would also multiply the amount of tablespoon in the original recipe by 5, therefore needing 15 tablespoons of oil. Ratio boxes show how 2 ratios maintain an equivalent relationship between 2 quantities using multiplication, again, or division. We're going to be using ratio boxes an awful lot to show these ratio relationships and later to find unknown amounts. So here we have the same example, 2 eggs for every 3 tablespoons of oil. So what if I had 6 eggs? How many tablespoons of oil would I need? Well, the ratio boxes are so cool because we can see a lot of different relationships just by what we're given and what we know. Notice that these are labeled and we can fit right in what we already know. We know that the 2 eggs have with 2 eggs we need 3 tablespoons of oil, so what if I have 6 eggs? How many tablespoons of oil would that be? The ratio box allows us to keep all of our ratio information very straight so we don't get it confused. Well, we can see all of these multiplicative relationships kind of like we were talking about on the table before. I know that from 2 to 6, that's times 3. And so that relationship would be maintained here. So 3 tablespoons times 3, well, that would be 9 tablespoons. But that's not the only way that this would work. If that's the way that works for you first and you completely understand it, go with it. The best thing about the ratio box is different students think different ways, and you're going to see different relationships. So now you're not tied down to one method of problem solving. You can also look here and you can go from the bottom up. You can move vertically from the bottom up. So how do I get from 6 to 2 multiplicatively? Well, there are 2 options. You could say, well, I multiply by 1/3. You could also say, well, that's dividing by 3. 6 divided by 3 is 2, or 6 times 1/3 is 2. Either way, if you look in the orange, 6 times 1/3, well, 6 times 1/3 is 2. This is where we say, well, we don't know what this value is. Well, but this value times 1/3 is 3. Here's where our equation knowledge comes into play. What number times 1/3 equals 3? Well, we use those inverse operations and we find out that x equals 9, which we knew already. You could also say, what number divided by 3 equals 3? Again, what number divided by 3 equals 3? Well, I have undone division and I've multiplied on both sides by 3, and that gives me that x equals 9. So far, we have gotten 9 as the correct answer in 3 different ways using multiplication in 3 different ways. We've also used division, but again, division and multiplication are so closely related, we call it multiplicative reasoning. And then also, the ratio boxes not only work vertically, and we're probably going to be most comfortable working vertically, but it also works horizontally. The multiplicative relationship from 2 to 3 will be the same relationship from 6 to 9. Okay, so how do I get from 2 to 3? Well, I know if I multiply 2 by 1.5, I get 3. And so therefore, if I multiply 6 by 1.5, I will get 9, and that is the truth. Okay, so you're going to see a lot of that as well. Here is more of an example you might be able to relate to. If you have ever been paid for babysitting, you've probably been paid per hour. This can be displayed as a ratio relating money earned to hours worked. I don't know if you've ever sat in a house while you're babysitting and the kids are sleeping and you're just counting the hours and you're counting the hours and thinking, how much am I going to get paid? Well, this is a multiplication problem. You may be doing repeated addition in your head, but it's really a ratio relationship. The number of hours you worked compared to the amount paid per hour is going to give you a total. So here, if you notice, we know that for every 1 hour, we're going to make $8. But what if I babysit for 5 hours? How much am I going to make? Well, I know that to get from 1 to 5, that's times 5, and I've noted this here. So that means that 8 times 5, I'm going to earn $40. Not a bad payday, huh? But here, we're working within hours, and I'm working within pay, and I know that this is times 5 times 5. We call this the within relationship, because we're staying within the quantity to do the multiplication. Within hours, 1 times 5 is 5. Within the amount of pay, 8 times 5 is 40. But likewise, if we have the same scenario in this ratio box over here, 1 hour, $8, 5 hours, how much? Well, I know from 1 to 8 is times 8. And this time I'm not staying within my unit, I'm going between units. From 1 hour to $8, 1 times 8 is 8. Well, likewise, 5 times 8 is going to be 40. And this time, like I said, I went between the 2 units. We call this a between relationship. Like I said, a lot of times we're going to be more comfortable working vertically in the ratio box. That's going to be our within relationship. But keep your eyes open and eyes peeled for the between relationship, because sometimes that might come in really handy as well. And then lastly, I have an important point to make. We're going to be working a lot with equivalent ratios, and a lot with proportions, and a lot with ratios in all sorts of situations. And it's important for you to know that finding equivalent ratios is very similar to finding equivalent fractions. However, ratios are not fractions. They're not. Fractions are numbers that can be represented on a number line. And ratios compare 2 separate quantities. Okay? So, if we want to find equivalent ratios, here's a scenario for you. There are 10 girls and 20 boys in 4th block. Find 2 ratios equivalent to 10 girls and 20 boys. Basically, what you want to do is maintain the relationship of girls to boys. Because the ratio is 10 girls to 20 boys, there are always going to be fewer girls then boys. It's important to note here that in a ratio, the order needs to matter. You cannot begin with girls to boys and end with boys to girls, because then if you just represent it as a number, if you represent it as 20 to 10, if I was talking about girls to boys, you wouldn't know which one represented what. And clearly 20 is boys, but we were talking about girls to boys, not boys to girls. And there are not 20 girls for every 10 boys here. There are 10 girls for every 20 boys. So make sure that when you're given an order, you maintain that order. Now we know that we can write ratios multiple ways. We are going to be working more with the fraction-looking ratio the most often, just to kind of keep with some mathematical consistency. So if we're talking about equivalent ratios, if I have 10 girls to 20 boys, we can find equivalent ratios very similar to the way we find equivalent fractions, maintaining that relationship, using the multiplicative identity, using a factor of 1 either to multiply or divide. Remember, with the numerator and denominator, with the two quantities, we want to multiply or divide by the same amount, okay? So if I have 10 girls and 20 boys, then if I wanted to, let's say, divide both of these by 2, then I would have 5 girls for every 10 boys. This is an equivalent ratio because I still have half the number of girls to boys, right? I could also say, I could even go with this one and maybe simplify the ratio to find an equivalent ratio. Well, 5 can be divided by 5, therefore so can 10, and I would say 1 girl for every 2 boys. This is the unit ratio, isn't it? The unit rate. 1 girl, 2 boys. There you go. I could also, if I started with 10 girls and 20 boys, I could say, well, if my fourth block expanded, I could multiply this by 2. If I multiplied this by 2 as well, then if I had 20 girls, then to maintain that relationship, I would have 40 boys. Okay?